Hello and welcome to Func Prog Sweden. My name is Magnus and I'm the host at Func Prog. Func Prog Sweden is the meetup for you that is interested in functional programming. And throughout the different meetups, we have explored functional programming languages such as Erlang, Elixir, Scala, Scala, F#, Elixir, and Clojure. We have also endeavored into other areas like C++ for functional programming, Java, C#, and also JavaScript. And today we're gonna go into functional programming in a database and also functional programming in an operating system. With that said, we'll go over to the agenda of today. So this is the agenda. First up, it's me. I'm doing a short intro. And then we head over to Marek and Datomic, a scalable, immutable database system by. And then we're going to look into Mac OS to Nix OS, the purely functional Linux distribution by Daniel Britton. And in the end, we'll do a short schedule and summary. First, I would like to thank Adabeat as the video sponsor. Adabeat is a consultancy company based in Stockholm, but also have an office in Ho Chi Minh in Vietnam. Most of the developers in Adabeat have a functional programming background, and if you want to know more about Adabeat, head over to adabeat.com or check them out in social media. Oh, wrong way. No, right way. If you want to support the meetup, and of course you want to do that, head over to the meetup community and join there. And remember to follow us here on YouTube also, in the YouTube channel. And if you like, you can also check out the merchandise store at funkprogsweden.myspreadshop.net, where you can get a Func Prog Sweden t-shirt, if you like. If you have questions during the presentations or thoughts, input, please use the chat and ask the questions and I will read them up for the presenters. With that said, let's get started. We'll have our first presenter with us. Marek, welcome to Func Prog Sweden.
Welcome, Magnus. Thank you very much for the invitation.
Yeah, you're welcome. And you're coming with us from all the way from New Zealand. So you're already ahead of time of us, 12 hours ahead.
Yes, that is true. I'm 12 hours from Central Europe, so it's early morning here.
How's the future? Is it good?
It looks fine. It looks fine. The sun is up, and also the future is the summer because we have summer now on the southern hemisphere. Yes. So you will enjoy the summer in half a year. It's awesome.
Great. Warm welcome. And let's get started.
All right. So my name is Marek Lipert, and good evening, everyone. Good evening. I am a CTO of Spinny. Spinny is a company that produces various kinds of software. It is based in Kraków in Poland. And we are trying to incorporate as much Clojure into Spinny as possible. And we are also using Datomic in production systems. So I can not only talk about Datomic, but maybe if there are questions after the presentation, I can talk a little bit about what we do in Spinny with it. So today I will be talking about, as was already introduced by Magnus, about Datomic. Datomic is a database that is based on functional principles, mostly the immutability. It was built by Rich Hickey, the same person that has created Clojure programming language. And it builds on Clojure foundations, although it is not only accessible from Clojure. People can use various programming languages to interact with Datomic, but the most natural way is through Clojure. So Rich has built Clojure because he thought that writing stuff in Java, which was one of the languages that he mostly used, was a little bit tedious and not productive. So he thought about introducing some Lisp principles into Java. He basically built Lisp on top of JVM with all the advantages of simple, clean syntax. And he added a lot of data structures. And also he knew that in order to introduce a new language into the ecosystem, you have to, now in 2022, or it was 2010 when he introduced it, but it's also valid now, you have to have a base of libraries. You can't just come out of blue and say, this is my new language, because people want to leverage what was already built over the years. So this was his choice of JVM. And now one of the cornerstones of Clojure and the actual research project that he undertook in order to develop understanding whether it is viable or not was immutable data structures. So he built those immutable data structures to be performant, and he didn't know will it work on JVM or not. And he got some scientific papers, he put them in, and to his surprise, it worked. So this was the foundation of Clojure. And it is not surprising to see that he used the same principle to build a database system. So for all of you who know Clojure, those 2 minutes might be very boring, but I just wanted to quickly introduce the language, which is very simple, so that, because I will be using some of the code examples later on. So in Clojure, everything is a list, and as in every Lisp. And those Lisps are interpreted by the compiler most of the time as function invocation. So in here you have an invocation of minus with 7 and 1, and then multiplication with 2, and the result of this minus 7 and 1, and so on. So the arithmetic looks a little bit odd, but it's very, it's a very fast process to get used to it. Now, this is the syntax for lambdas. So lambdas are created with fn form, and you can see that there's an argument, a vector, and then the body of a function, of course, no return. So it allows to produce very concise code. Like, for example, using just the star operator as the name of a function in reduction is possible because of this syntax. Most languages would not allow you to just put just a star operator as a multiplication function. Now there's also therefore basic data structures. So there's vectors, there's lists. This list has to be quoted because lists by default are interpreted as function calls, and we don't want to call 1 on 2 and 3. There are sets, and of course there are associative maps. Forgive me. And all those data structures are immutable. So yeah, this is the data structure access. So we can just use keywords as functions to extract stuff from maps, for example. This is the function definition. So it's very similar to lambda definition, but it defines the function as a symbol in a local namespace. And this is how we write recursive functions. So there can be 2 different argument sets. So you see that the function has different form depending on how many arguments are used, 2 or 3. And the recur form, this recur form allows us to, go back recursively, and it also ensures that the tail recursion optimizations are being employed in here. Yes, so we can just use this function and observe the result. Yes, I think that's all about Clojure. And now the demo of this immutability. So when we have like a map that's called zoo, we can do an ASOC in, which means that we go to the element of elephant habits and the second entry, and we could just add this entry, the sleeping entry into it. That's, by the way, that's also very concise and interesting syntax. I once had the pleasure to attend a meeting that was on the meeting, the speaker was explaining a library that they wrote for JavaScript to allow similar functionality. But in Clojure, it's built in, and as you see, the data structures, they share memory with each other. So even though we do this ASOC in, the zoo is still the same as it was, and it's all performant, and it's occupying memory only once. Okay, so let us move on to the database design. So our database, since I currently live in New Zealand, the database will be based around animals. And I also used to consult with a company that was doing a lot with animals. So this is a very good topic for me. So let's say that we're talking about those animals and we have certain fields in the database, right? So there's this cow. The EID tag is something that they have in their ear and can be read by a special stick. And this is like a unique number of an animal. And they use this in all the farm management software. Okay. And now, most of the database systems would, when you, for example, change something in the data row, they would say, okay, so now this cow has age 16 months, probably. And we take this for granted. But when we think about it, it's not as obvious. Like, first of all, is the cow during the next month the same animal as it was in the former month? Like, one could say, yes, obviously it's the same cow, but the time flows, the cow could develop, I don't know, like a little bit more muscle, or it could become sick. And it may not be the exactly same cow. So this is more like a philosophical question, but in Datomic, this question is at the core of what we do. And when you look at the past, when people kept records in the past using paper, like, for example, ancient Egypt, they would never be able to replace some variables in their notes, right? They would always add new notes because, they would keep all the former records for audit, for inspection. So in some ways, it's very natural to think about those things as, different things. It might be, not exactly the same cow. Yes, so this is a demonstration of another change in a normal database, so that the original values are lost again. So the weight was increased and it's just gone. We see the new weight, but we don't have the foggiest idea what was the weight in the past. And now the question is, well, are those the same animals now? Because, the species has changed, the sex has changed, but the EID tag remained the same. And this also happens people tend to reuse EID tags. And obviously, if we base our data rows in the database on this EID tag, then we have a lot of problems, because suddenly, in our system, this animal has changed its species, and maybe this is not something we want to have in the system, right? So I brought those examples here to demonstrate that thinking about the state in a way that it is as it is now, and we don't think about what it was in the past, might not be the most accurate approach in various applications. So Datomic works as a system that just takes notes. So this is an entry from, let's say, Datomic database. And you see that it does not change anything. It just stores new facts. So some people say like Datomic is the data store for facts, not for objects, because you see that there's no object in here. There's only facts, and there is this entity number that's displayed in here, but this only means that those facts are associated with a certain entity, but they can change the species, and you can see it all. And they are ordered according to the time they were installed. So the time flow in the database is a time of subsequent transactions. Yes, so I will show this example in code. So we use Datomic, and now we do a transaction which just adds certain information into the database. And then later on, we can do a different transaction that modifies the object, not modifies the object, but adds additional facts throughout the database. Each line of the transaction is called a datum. So you see that it's a vector that contains other vectors. So this is the form that the Datomic accepts its inputs. So it's the operation name, the entity number, then the field that we want to modify, and the new value. Okay. And yeah, the third one changes the species, right? So this is the third operation. So, so as a summary of this section. So as humans, we used to write and accumulate our records. Never did we modify them. In ancient times, and also in a lot of paperwork we do, we only accumulate facts. And computers give us the ability to see the state of the system at any point in time. So this is something new that the ancient Egyptians didn't have. So we can, in Datomic, we have access to this illusion that the system works as an ordinary SQL database, but this illusion is for reading only, and we can view the current state. But this system also allows us to travel in time and to say, for example, that we want to see the whole system as it was 3 weeks ago, and then we pass we pass the date variable to the database creation, let's say database creation code, and then suddenly we can see everything as it was in the past. So I think I don't have to tell you how useful this can be during debugging, because you can go through all the events that happened in the database, one by one. You can even log metadata. So for example, in our system, we log the request, the IP address the request was from, on the backend system. And then we can understand in full glory what was happening and when. Okay, so the next step, I will show you how you describe the database schema in Datomic. So another interesting feature is that there's no division into tables. So you can think about Datomic as a single table, and certain rows might have certain attributes, but at any time you can add or remove entries according to your needs. So for example, when we we can create those, let's say, the DB idents. It means that we are creating a possible field for the database. So for example, this ear tag EID, right? And now the prefix doesn't matter, it's just for organizing the data. So we can think of this as helping us out. And it can have things like animal, for example, just to associate them with animal, but there's nothing stopping us from giving animal / for example, weight to a car that we have in the system, right? So this has to be designed very wisely. And of course, it wouldn't be the best practice to give an attribute called animal.weight to a car, right? We would rather have something like, I don't know, general attributes / weight, and then we could associate it with different things. So this flexibility, it sometimes freaks people out, but I really enjoy it because, you can add some attributes later on and not be worried that you have to go through some kind of migration or some, modification of the table. And you're also not worried that in the table, for example, tons of animals can have all those fields that are listed in here, but there could be one animal that has one additional field, only one animal, right? And then you don't want to create a separate column to just store this one additional fact for a single animal, right? And by the way, the schema is also a set of datums. Those datums in here, this is like an alternative way to write datums because it used to be a vector in the past, but now it's written as a map, but it doesn't matter, it still works. So it stores those facts as any other facts. So in some ways, the schema is contained within it. And those entities, as I say, they can be modified. So we can add additional things in here, like farm names, paddocks, and combine them in whatever way we want. And now this is an example of a more advanced schema. So we can have some relationships, right? So there could be a paddock inside of which the animals reside. And we could associate animals with paddocks as it is visible on the bottom of the second slide. Now I will present you the query language. So this is an equivalent to SQL select statement. And it is constructed so that it's a data structure within Clojure. So you see that there is a vector in the query form, and this vector tells us what do we want to get, right? Then it tells us that this in can accept parameters from outside. So the only parameter here is the database snapshot. So it shows at the very bottom as an argument to the function. And then inside the where block, we're just listing the requirements that we want. So we want the animal to have certain temperature. We want the animals, we want to extract the age, right? So this is also something that we write. And by combining those forms, we can arrive at the query. The queries can be more complex, like they can include or and forms, but this is the basic idea of how we query in Datomic. So this is an example of what I was saying. So when we go back in time to the time that where we had no paddocks, then this query will not return anything because there was no such facts accumulated in the database at that time, right? And we can also see that this animal and age are as they were before. So in this way, we can see the past. So you see that, this compares with the table. So when we have the date set at 2021, so this first transaction, the subsequent facts are not visible. So only the facts that are marked in blue are visible to the system, and that's why the response is as it is. Okay, so now we'll be talking about the design of the very system. So Datomic selects a systems approach to not reinvent the wheel, and storage is separate and uses existing solutions. So for example, in our company, we're using DynamoDB for storage, and you can think of Datomic as just like a program that works on top of it, does a lot of caching. The unique thing about this database is that Rich has chosen it to be sequential. So there's only one, let's say, process that is allowed to write at one time. So there's something we call transactor. All the clients are connected with a transactor, and when somebody submits a transaction to a transactor, the transactor will not process any subsequent transactions until this one is done. So this way we can keep sane with writing, and so writing doesn't scale. But when it comes to reading, we can scale however much we like, and we can use some caching software, like for example, Memcached, to allow for even quicker read access. And since we have a single transactor, the full asset is ensured. So this is similar to an SQL database, that we have certainty that if we write something, it's actually written to the database. Yes, so query, transaction, and coordination and storage are separate services. When it comes to queries, so the funny thing is that when you are using Datomic on premise, you can have the query engine that is embedded into the application you write, which means that in some ways, this library is like a database that is being run on your local machine or on your server. So this means that there's no latency between the database and the application because they're in the same, let's say, JVM. They reside in the same JVM. Yes, and there's also an option to use SQL or Cassandra as an external storage. We've chosen DynamoDB because of its other properties. I will not go deeper into this for now. Yeah, and as I said, it's ACID for writes, high availability and scalability for reads because of immutability. So you can read from various versions of this database, and it's all fast. Now, when it comes to partition tolerance, in CAP theorem, we have C and P, which means that if transactor is not available, we can't access the database. So, but transactors can be run in pairs, so that whenever one of them goes down, the other one takes over. So this mitigates this problem. But in this theorem, CAP theorem, you can only select two letters. So that's what they've selected. And now I'll talk a bit about the architecture. So write performance is dependent on the single transactor. You can see the transactor in the bottom left corner. And the transactor is also responsible for writing to the storage. So the write throughput would be similar to a standalone SQL server. But because of immutability, read operations can be parallelized and aggressively cached. So this allows a lot of scaling for the reading. And now there's two possible architectures, you see. One that we use in Spinning on the left. This is where the peer library is integrated with your app inside JVM. And there's also another architecture possible when you have something called peer server, which does all the caching and it acts like a front end of the database. So it allows other clients from other languages to connect over HTTP and get information as from a normal database. And this means that if you use the architecture on the left, there's no n+1 query problem because there's no latency. You can do queries however you like, in however sequence you like. And since everything is very aggressively cached, most of your queries would result in something almost immediately. And you can divide your query, or you can do a one big query. It doesn't matter that much as it does in SQL databases where the latency could kill you. And if you're doing a million of small queries, it could be way slower than a single query that extracts a million lines, right? Yes. So again, the primary components are the storage services, transactor, peer library, peer server for this, let's say, right-wing architecture, and client library, which is available in various languages. Now the sour part. So unfortunately, Datomic is not for free. They've built this system in order to apparently, sell it. So the licensing goes like this. There's a viable free version, and there's also a pro version that is being licensed to you for free, but it has no support and it has access to updates only for 1 year. And after this, if you want to use the on-premise version, you need to buy a license if you want to get the updates and support. And the other solution is to use Datomic Cloud, which is just some added per hour cost on AWS. So I think the team on Datomic, they've been putting a lot of effort into this option throughout the last few years. And I think this is the preferred option now because it's so easy to build, you just pay a little bit more for your EC2 instance and you get all the benefits of this system. All right, so I think this is all I wanted to say. Thank you very much for your attention. Are there any questions?
Yes, thank you very much, Marek. Thank you very much for your presentation. Thank you. Yes, we actually have one question. One question is, could you elaborate a bit what's the difference between the Datomic and a normal relationship database? I mean, what's the pros of using a Datomic database instead of?
Thank you. Yes. So the biggest advantage of Datomic over the normal relationship database is the fact that we store all the history, and this history doesn't get lost. So, for example, when you change something in a normal relational database, you have no access to the information of what this field was before. Like I spoke about the age of the cow. So when we change in normal relationship database, when we've had this cow, just quickly go through it. So when we change the age of the cow, the information that the age was 15 in the past is lost. And what is being given to us by Datomic is the access to this lost information. So we can traverse the database even in a way that we can go and say, give me all the events that happened to this animal or to this entity, whatever it is. And Datomic would give us all the transactions that have ever modified this entity in any way. And thanks to this, we can do a lot of stuff. So it's only up to your imagination to figure out how to use this functionality. We use it mostly for bug detection and fixing, and also for reproducing some strange scenarios that happened in the past. But you can also use it to query the database. For example, imagine we've been in a situation when we wrote an application that is similar to Uber Eats. So it's a delivery application that allows you to deliver food. And now we had this problem that, when somebody, imagine one person editing some food, like changing price of food, and another person that has already ordered the food, right? So you don't want the food to change in the middle of the process. You don't want the, like, let's say that somebody has edited, not the price, but sorry, let's say that they've edited that it's with ketchup now, right? With ketchup now. And you don't want the person that ordered a food that doesn't have ketchup to be given a food with ketchup if a manager edits this line. So you have to keep all the versions of the food together, because there might be still people that have ordered the past versions of food. And Datomic solves this problem very beautifully, because you just remember the time at which something was ordered, and you access the database as it was when the thing was ordered, when you cook it. So that's one example where it helps. And now it is not true that SQL doesn't have this functionality. You can build this functionality into SQL by, creating a new row for every entry, but not many people do this. And this is also quite taxing on the database. So SQL databases are not prepared to be, let's say, a store of facts. They're rather tailored at being store of values.
Yep. How do you see, when you do that, I mean, I assume you like, it's kind of if people are interested, you can look into event sourcing. It's kind of the principle here. Would you agree on that? That you event source, that you never forget anything, that you just add, like a ledger?
Yes, exactly.
Yeah. How would you see data growth? Because you will eventually, you will. Have you seen issues with data growth, or is that, no, we haven't seen? I mean, we buy more space in the cloud, and who cares?
No, so how Datomic is built, it has certain limits on the size of the data that can be there. So Cognitech, which manufactures Datomic, they say that it can easily work up until 10 billion of data. So 10 billion of facts to be stored, but you can create shards within the database to alleviate this problem. Like you can have different, let's say, sets of information that sit in the database. But because of how they've structured in the indices, that's how it is. So obviously we haven't encountered this problem, because in our products, we don't store like this much data. But what Rich always says is that, not every database is for every job. So
True.
Datomic is not something that should be used, for example, to store log files, right? And you could say the same about SQL databases. The databases that offer you more functionality are better employed to store, for example, financial information, information that is valuable for the company and that you want to ensure its correctness. Whereas, for example, if you were to store log files or some millions of lines of some, random streams coming from Internet of Things devices, you would rather use a normal NoSQL database, like, for example, Raw Dynamo, or I don't know, Mongo or CouchDB. So it's not for every for every use case. It's for a use case that is more like tailored at safety and full ACID capability.
Got one more question. Like, how suitable is it for real-time capabilities around?
Okay, so since it's based on Java, right, so on JVM, and it's the Clojure as a language it was written in is also a high-level language. It means that it uses garbage collection. So I would say that as far as this is not a problem, then it can be used in real-time systems, but I would hesitate, because, in real-time systems, you want to have full control over what's happening, and you can't allow garbage collector to run in random times, right? So I would say it's not suitable for real-time systems. For real-time systems, the database written in low-level language would need to be employed, like in Rust or in C.
Yes. Let's see if we have more questions. Is there a Docker version of Datomic?
So we've built Docker containers ourselves, but so it is not easy for me to say. I've never researched like pre-made Docker containers for it. We were based on just on like simple Java JVM containers, and then we add Datomic from there on.
Yeah.
But yeah, so sorry, I can't answer this question, but I think it's easily Googleable.
Yeah, it should be. Okay, so the question was like, yeah, the question is like real time. Let's put it like this: does Datomic have any mechanism to notify about changes happening in the database?
Yes, so there is, and by default, all the peer libraries are directly connected to Transactor. So in the background, Transactor notifies everyone who is attached to the system about the changes.
Okay. Great. I don't see any more questions. Thanks again, Marek, for your very nice presentation. It was very good. Thank you very much.
Thank you very much, and thank you for the invitation again.
Oh, you're welcome. You're welcome. Thank you very much.